Okay, applications of trigonometry. First part is compass bearings, and another one will be true bearings. Let's have a look at the compass bearings. A bearing is a direction according to a compass. So the main one will be north, south, east, west, and there's a halfway between north, south, east, west are northeast, northwest, southeast, southwest. As you can see, there's a pattern here. It starts with the north or south. It's either north or south. It doesn't start with the east or west, but it's finishing with east-west. Okay, so remember that. So that's what I mean by compass bearings in between. Okay, so and then when we write a compass bearings with north-south. Okay, already told you about that one, and it looks like this. Okay, something like this. Now true bearings, it's always starts from north. Okay, true bearings. True bearings measure angles clockwise, so it's going from, say, from north to this way. It doesn't start from anywhere other direction, so it starts from north. And then we say B is on a bearing of theta from A. It looks like this. So B is on a bearing of theta from A. Now this is the important part. From A is always the starting point where it actually starts the bearing. Okay, just below the north. Okay, so true bearings, also another important part, is uses the 3 digits from 0 degrees to 360. Okay, so for example like this. So acute angle, you need to put 0 in front. Okay, next one. Let's have a look at some examples. First example, I don't know whether I can push this one up a bit better. Okay, draw a diagram to show the bearing. Okay, so this one is what? Compass bearing, isn't it? In between. So it starts from south and it's 80 degrees east. So how do we do this? So it starts from south and 80. I'm going to go to 80 from here using the ruler roughly. So that's from here to here is 80 degrees. So that's this one is what we call S, 80 degrees east. Okay, next one, north 40 degrees west. Okay, I forgot to put west here, so I'm going to put it back here. Okay, so it starts from north and the west, so it's here, this part. So north, going north 40. So that's 40 degrees. And this is what we call north 40 degrees west. Okay, so that wasn't too bad. So next question. Okay. Let me show you all of them. Find the bearing of X from, remember, from Y. That's the starting point. So Y is your starting point. Using compass bearings, and that's part 1. Part 2, true bearings. So it's just a different expression. So part 1, compass bearings. Remember, compass bearings in between. So it's always start from north or south. So here it's starting from north. So I'll go north 23 degrees and west. Okay, that's my compass bearings. Now, true bearings always start from north all the way. Okay, so this is the part that we have to look for. Now, it's not too bad because, what is it? Whole circle is 360. So if I do 360 take away 23, that'll be my bearings, wouldn't it? So I will go 360 degrees take away 23 degrees equals 337 degrees. So that's my true bearings, and you got 3 digits there. Okay, so that wasn't too bad at all. Next one. I'm going to show you a whole lot. Let's see. Okay, so Jack is on a bearing of 260 from Jill. So from Jill. So Jill is the starting point for us, wouldn't it? Okay. What is Jill's bearing from Jack? That's we're getting two starting points, which means two sets of the compass here. So this is my first one when Jill was the center, the starting point, and the bearing was 260. Now, because it starts from north, that's 0 degrees, and going to east is 90 degrees. From there to south, it'll be 180, south to west, 270. So bearing of 260 is just less than 270, so it's here. So that's my bearing, and then it suddenly says Jill's bearing. We have to find the Jill's bearing from Jack. So my starting point will be now from Jack. So I had to sketch another compass here. So first one and second one. And remember, it always starts from north. So that's the bearing, Jill's bearing. Okay, Jill's here. We have to find. Okay, so how are we going to find this? Because that's the same, this angle is the same, because that's when you sketch, doesn't really matter how many compasses you're going to sketch, you need to have parallel to each other, so that it would be handy for us to find the angle, wouldn't it? So it would be, this is alternate. Okay, now what's this going to be is 260 take away, what's this part? 180, isn't it? So 180. If I do that, I will get the theta. So let me write this down. So 260 degrees, 180 degrees will give me 80 degrees. Okay, so that's my theta. Okay, so I'll just put theta there. But because it's, when we talk about finding a bearing, it's always like mostly likely true bearing, unless they tell you to write it a compass bearing. So it's a true bearing. Now this one has only 2 numbers there. You have to have 3 digits. So your final answer should be something like this. Okay, that wasn't too bad. Next question. Okay, example 2. All right, so it's a bit long, but that's not too bad. It's not too bad. Okay, so a train depot has train tracks running north for 7.8 kilometers, where they meet another set of tracks going east for 5.8 kilometers into a station. What is the bearing of the depot from the station? From the station, guys, from the station, not from the depot. So we have another a compass there. So I'm trying to find, was there any from depot? No. So let's have a look. Oh, it says here, a train depot has train tracks running. So that's sort of our first. So depot was our first starting point, and then we're moving into the degree. Okay, so that's not too bad. So let's have a look. If I sketch this, if I have to sketch this, okay, that's my depot. Okay, that's my north. And it says here, going to north for 7.8. And then it goes to the east for 5.8 into a station. So that's my station there. And then I'm just going to have to sketch another one, because it says we have to find the bearings of the depot, this one, from the station. So that's the bearing we have to find, that's north. Okay, so let's have a look. Exactly the same, but better looking diagram. Okay, so if I can find x here, I can take that x away from 270, isn't it? Because it's 0, 90, 180, 270. Then I can find the bearing of depot from station. Okay, so let's do that. So first part is the bearing will be 270 take away x. Yes, that's what I was explaining to you. So to find the x, I'll just sketch that triangle again and label it first, and then we have to pick SOHCAHTOA. So it's O and A, which is, yes, 10. And when you do that, I'll get 53 degrees in 22 minutes. Make sure you use a calculator, and to convert to a DMS, you need to press this button. All right, so after that, we need to take that away from 270, and it's to the nearest degree, so it's 217 degrees. All right, it wasn't too bad, wasn't it? Yes. So don't panic when you get lots of wordy questions. You just have to break things down. Okay, example 3. Jessica leaves home. Questions like this, your starting point for first compass will be home. Okay, so Jessica leaves home and walks for 4.7 kilometers on a bearing of 75 degrees, and she then turns and walks for 2.9 kilometers on a bearing of 115 degrees. So that's already, I can see two starting points there. One starting point is 75 degrees and one is 115. Okay, and she is then due east of her home. And what is the furthest north that Jessica walks? And that's the first question. Second is, how far is she from home? Now let's sketch this before we do anything else. So I'm gonna do north here, east. I don't think we need the south and west. So Jessica, can't really see that. Okay, if I do that, that's better. Okay, Jessica leaves home, so my starting point is home, and walks for 4.7 of bearing. That's 75, and that's 4.7, and then she turns and walks for 2.9, so on a bearing of 115, so it's about there. The 115, that's north, 115 degrees, and it's 2.9. And then what happens? And she is then due east of her home. Home's here, east here, so what happens here? It meets here. Okay, that's what it means. All right, let's have a look at the diagram. Much better, neat and nice. Okay, so question says, what is the furthest north that Jessica walks? So then we need to find, Jessica is here, and then she has to walk. That's our north, isn't it? Yeah, that's north. So to find this, I'm going to use this triangle. Okay, this triangle, because then I've got this 90 degrees here. That's what my opposite, and that's my hypotenuse. So I'm using O and H. So it's a SOHCAHTOA, so it's a sine. So if I do that, I'll get 1.2 kilometers for X. Okay, that's not too bad. And then B says, how far is she from home? So how far is she from here? That's a Jill here, Jessica. So Jessica in here. So we're looking for this distance right there. So I've just re-sketched this one. Now I'm gonna name the middle part as a K. You don't need to, but it's easier for me to then find the whole distance. So I'm gonna call the whole total distance as a J, and the J is obviously the distance from H to K and K to J, adding all up. So let's find HK first. So I'm going to find this one, yeah, using this triangle. So it'll be like cos, wouldn't it? Because SOHCAHTOA cos would be A and H there, cos, so A over H, which is A is the HK over 4.7 and cos 15, you will get that. Now, when you are not getting a final answer, just make sure you don't just put one decimal place answers. Put as many as you can, because it's the more decimal places during the process of working out, you'll get a more accurate answer. And then KJ is this one. I'm just looking at this part. So this one is what we're looking for here. That's opposite here, and that's hypotenuse. O and H. O and H is sine. So sine 65 is what? O over H. O is the KJ. H is 2.9. And that's what we got. And then when you add it together, you will get 7.1 into one decimal place.